I'm Anka Cotwell, and I'm an engineer on the Android Developer Relations team.
Hi, I'm Chris Broadfoot. I work on the Google Maps Android API team.
Today we're going to talk to you about the Maps API for Android, and we're going to cover a few things, but to start with, let's talk about animation. If you have a look at the sample code for the Maps API, you'll see that we use handlers to animate markers, and for other purposes too. So what we're going to talk about today is how you can use handlers for backward compatibility, but use some of the newer APIs, i.e. the property animation framework, to have an even better experience. So let's switch to the tablet, and let's just see a basic marker animating. All we're doing is where we tap, we just generate a polyline from the source to destination. Yep. Just tell the marker to move there.
Yep.
So here, we've accomplished what we wanted to, but as I said, in Gingerbread, Gingerbread and older, what we would do is animate these markers, the marker's position, using a handler. So let's have a look at some code that shows us how we do this.
Okay, so we'll be showing you 3 ways of animating a marker, and each of these methods will have the same parameters. So the marker itself, the final destination, lat long, so that's its final point, and a lat long interpolator, which we'll talk about a little bit later. From Gingerbread and before, we need to do a little bit of setup to set up our animation handler. So first of all, we get the start position just by calling get position on the marker, and then just again some of that setup, so just the start time and our animation duration. So here's the meat of the animation. So this runnable gets called every 16 milliseconds while the animation is in progress. The T variable is the portion that we are through the animation, and we're also using an interpolator. So these are available before Ice Cream Sandwich and Honeycomb as well. So this is great for like a accelerate, decelerate interpolation or a bouncing interpolation. And then we just go ahead and call that set position on the marker with its new value.
You'll see at the end of the handler what we do is we re-invoke the handler after 16 milliseconds. And of course that magic number is used so that we can get 60 frames per second. Now, one of the downsides to this is that we're doing this asynchronously to the Android UI rendering thread. So what we can do is use the property animation framework, and we're going to shift to the next one and see in the value animator how we can synchronize those.
Okay, so from Honeycomb onwards, we can use value animator, as Anka said. So here we still have to do a little bit of setup. We get the marker's starting position, but the value animator can give us the animated fraction. So this is the combination of how far the animation is through and also the interpolator. So any accelerate, decelerate is applied to that as well. And so we just again call set position on that.
So the on animation update override, it gets invoked as the next frame is being prepared. So literally, that's your opportunity to do whatever changes you want to make, and then the frame will get drawn. Unlike the handler, which is just going to happen every 16 milliseconds regardless of when you're drawing your next frame, this happens synchronized with that rendering framework. Now, the interesting thing is, or important thing is, you want to make sure you complete your execution within 16 milliseconds, otherwise you're going to miss that draw and you're going to get jank or jitter. The actual animation of the value, we're not really using that. As you can see, we say ignored because we're animating from 0 to 1, but we're not actually utilizing that at all.
So let's talk about Object Animator, which is also available from Honeycomb upwards. But Ice Cream Sandwich adds some other nice options, I suppose. So here we're using an Object Animator, and we can just create, so if you see down on this line, we just create an Object Animator of the marker and its property position. We pass it in a type evaluator, which basically tells the animation framework how to animate between custom object types. So in this case, it's a latitude, longitude object. And we just passed in the final position. So there's no need to call marker.getPosition at the start of the animation, which is quite nice. So the type evaluator is very simple. In fact, it's very similar to our lat long interpolator object, which we'll show you in the next section.
So the other advantage that I can see here is that we've actually got significantly less code to do this now than when we started. So you can obviously group properties, you can group different objects in here as well, so you can animate things in bundles.
Yeah, this works well with a properties value holder, for example.
Yeah.
Great.
All right, so that's animation. Now let's switch back to our tablet. Chris, why don't you walk us through the next problem?
Okay, so our animation is very simple. We're just animating the latitude and longitude values of the lat-long object separately. So this has some problems on the surface of the Earth where things wrap around the dateline. So at the 180th longitude, it's actually the same point as minus 180 longitude. So you'll notice if we try to animate across, the mark is going to go all the way around the world instead of taking the shortest path. So we can fix this very simply. Let's go over to the code. So here's our broken interpolator. It just takes the lat and long and takes a linear interpolation of each value. And our fixed one just figures out whether we should take a shorter path or not. So it just sees if the distance it needs to travel is more than 180 degrees.
So let's switch back to the tablet and just see what happens there. So this is the broken one where we're traveling around the world to get to that shortest distance. If we just switch to our fixed one, you'll notice that we get that path.
Yeah. So it's very simple. So you may notice that the marker doesn't exactly follow this polyline that we've added to the map. So the polyline that we're using has a geodesic property, which means that it's taking the shortest path on the surface of the Earth as opposed to a straight line on the surface of the map. So we can, if we wanted our marker to follow the polyline, we can use similar spherical mathematics to do this interpolation instead.
So switching back to the laptop.
Yeah, so this one's quite a bit more complex. You probably won't be writing this function yourself. Instead, you should probably just copy and paste it or include the Android Maps utils library. But basically, it just does this spherical math. So if we switch back to the tablet, we can.
So here it is broken, just to show you that it's actually not following that line.
Yep.
And let's switch to spherical.
Yep. So let's go near the poles, for example, where this is more obvious. So yeah. So you can see there's quite a large bow, and the marker's following the line exactly.
And if we go back to the broken one, you'll see that it literally just cuts across.
Yeah. So so the spherical method is very useful if you want this marker to follow a line, like we are here, or if your markers have some sort of actual geographic importance, like perhaps a plane on the map or something like that. Just animating the latitude and longitude separately is fine for short distances, or if you don't really care about any geographic properties. And it's probably quite a bit faster than the spherical methods. There's a lot of maths in there.
Yep, so please do check out the code that we have here. We'll put an annotation into the video.
It's going to be on Anchor's face.
And we hope you found this useful.